Hi, in this video we will be demonstrating how we implemented collision detection in our final project. So in our final project, we basically remade the mobile game Flappy Bird using some textures from the popular 3D sandbox game Minecraft and the 2D sandbox game Terraria using JavaScript, HTML, and webgl. Because our project was based on Flappy Bird, everything mostly takes place in the X and the Y axis, and therefore simple 2D collision detection was enough for our needs. But the concept can easily be applied to the Z axis as well. So to implement collision detection in our game, we need a few things first. We need a way to track object positions in our game. Now our project makes use of an entity components systems model where every entity or object in the game has a position component representing that entity's position in the game world. We also need a way to track the object's bounding boxes or hitbox, which is basically a box that determines the overall size of the object that we're trying to check for. And in our project, we used our entity's scale component since most of our objects' entities are boxes already. And lastly, we need a way to check if our objects' bounding boxes or hitboxes are overlapping each other, which is what happens when two objects collide. So in our project, the game will check for collisions on every update frame, just before everything is drawn on screen, but after all the entity movement is applied. So how do we check for a collision? And well, in our project we implemented a simple algorithm to check for 2D collision. Basically, we first check if there is an overlap in the x-axis between the two objects, and then we do the same for the y-axis. Finally, if there is both an overlap on the x-axis and the y-axis between the two objects, then there is a collision. And you can also implement this for 3D collision detection by checking for overlaps on the z-axis as well. Okay, so to check for overlaps on the x-axis, we first need to get the minimum distance between the two objects on the x-axis before they overlap. This is called d0, and it's represented right here on the far right. This is the minimum distance before the two objects overlap each other. So once we have d0, we can check for overlaps on both the left and right side of the x-axis by getting the distance between the two objects on the x-axis. This is represented by the variable d here. And once we have that, we just compare the two distances with each other. If the distance between the two objects is smaller than d0, then there is a collision on the x-axis, or there's an overlap on the x-axis. And likewise for the y-axis, we do the same thing. We first find the minimum distance between the two objects on the x-axis before they collide, represented again by d0. And then we get the positions of the two objects and we compare the y positions this time of the two objects. We compare the distances between the two y positions. And then we check to see if the distance between the y positions is smaller than the minimum distance between the two objects before they start to overlap each other on the y-axis. If it is, then there is a overlap on the y-axis, and if it isn't, then there is no overlap. And finally, to put it all together, we check if there is both an overlap on the x-axis and an overlap on the y-axis. And when there's both an overlap on the x-axis and an overlap on the y-axis, we can see here, represented by this red box, that there is a collision. So now that we've detected that there's a collision, we can now write code to handle the collision. So now I'm going to demonstrate the sections of our source code that correspond to the slides, and then I'll demonstrate the collision detection algorithm in action. So in our source code, the function that handles collision detection is right here. And basically, we get the positions and scale components of the player object, and then we get the collection of all entities that we want to check collision against, and then for each of those entities we get their position and scale component as well. So then we start checking on every update frame whether or not there is an X overlap either on the right side or the left side, and we check if there's a Y overlap on the bottom side or the top side. And at the end of it, if there is both an X overlap and a Y overlap, then there's a collision detected, and then we handle that collision in this bit of code here. So now I'm going to demonstrate the collision detection algorithm in action. Alright, so here we have a simplified level with only two blocks, the player block and a collidable block. And we can see that when there's a collision detected, that the diffuse component changes. The block blinks when there's a collision. And it works on all sides. And now we can see this in action for the actual gameplay. Oh, oops. Yeah. Oh, I know what happened. Forgot to reset this variable here. Where is it? Right here. Okay. So we can see the moment the player cube collides with a game over entity, the game over screen shows up. The collision is handled. And we can keep testing it from all sides. Like if we collide from the side, the collision detection detects the collision and the game over screen is prompted. So that concludes our video presentation on how we implemented collision detection, and we hope it has been informative. Thank you.